Okay, so I want you to picture something. I'm pretty sure this has happened to, like, everyone at some point. You're driving, you're behind the wheel, and the person in the passenger seat is supposed to be navigating. They're holding the phone, looking at the map,
The designated navigator.
and they say something with absolute confidence, like, okay, turn left at the big tree.
The big tree. In a world full of trees, that is the classic start of an argument.
Exactly. You scan the horizon, you see an oak, a pine, maybe one of those cell phone towers that looks like a tree. You hesitate, and in that split second, the vibe in the car shifts from fun road trip to worse, right? And usually we blame the person. We say, you give terrible directions or you aren't being clear.
We blame their communication skills. We just think they didn't pick the right words.
But what if I told you that the failure of that conversation wasn't about their tone or their grammar or even the specific words they chose? What if we could predict that you were going to miss that turn with, like, 96% accuracy just by looking at the mathematical shape of the conversation?
It sounds like science fiction, doesn't it?
Hmm.
Being able to predict the outcome of a dialogue without even knowing what people are talking about, just looking at the structure.
It sounds like magic, but it's actually network science. Today, we are deep diving into a study that honestly blew my mind. It's titled Structural Topology and Efficiency in Dialogue Lexica.
It's by Zhenhai, Kuyu Chang, and Jung-Jae Kim.
And essentially, they built a model that just strips away all the emotion and the noise of a conversation and looks at the bare metal structure, the wires and the beams that hold our understanding together.
And the results they found are, well, a little unsettling for anyone who prides themselves on being a descriptive speaker.
Unsettling is the right word, because they found out that the secret to being understood, to actually clicking with someone, comes down to one specific part of speech. And I'm going to spoil this early because we have to unpack it. It's not verbs. It's not adjectives. It's not about painting a pretty picture.
No. In fact, the study suggests that sometimes trying to paint that pretty picture, adding more detail, it actually creates data noise that makes you less likely to be understood.
So buckle up. We are going to look at the math of why we misunderstand each other and how a model called Titan might just solve the problem of the passenger seat navigator forever.
I am ready. Let's do it.
Okay, so let's start with the basics. Before we get to the complex graphs and all the algorithms, the researchers had to ground this in psychology.
Right.
Because you can't measure communication if you don't know how the brain actually does it. They reference something called the interactive alignment model, or IAM.
Right. IAM is the foundation here. So the old way of thinking about communication was sort of like a game of catch. I have a ball of information, an idea in my head, and I throw it to you with words.
Yeah.
If you catch it, boom, communication happened.
That feels intuitive. I have a thought, I speak it, you hear it.
But IAM says that's way too simplistic. It suggests that dialogue is actually a process of synchronization. It's not just moving data, it's aligning our mental states.
So less like playing catch and
more like two jazz musicians trying to get in tune with each other during a jam session.
So we're syncing up. But syncing up on what? Just the vocabulary we're using?
It happens in layers, almost like a pyramid.
Okay.
At the very bottom, you have phonetic alignment.
Yeah.
You might, unconsciously start mimicking my accent or the speed at which I talk. If I whisper, you whisper. Then you have lexical alignment. We start using the same words. Then syntactic, using the same sentence structures.
And what's at the top of the pyramid?
The holy grail. The situation model.
The situation model. That sounds like something from a military briefing.
It effectively is. It is the shared multidimensional map of what is going on. If we're talking about that drive, the situation model includes the car, the road, the destination, and yes, the tree.
And if my mental map has the tree on the left and your map has it on the right,
Our situation models are misaligned.
and no amount of yelling turn left is going to fix that because we're basically navigating two different realities.
Exactly. And the mechanism the brain uses to fix this, to sync these maps, is called priming.
I love the concept of priming. I usually hear about it in like marketing psychology. If a store plays French music, you're more likely to buy French wine.
It's the same underlying mechanism. In this study, they look at how words prime other words. And there are two types. First, there's direct activation. I say beach. And your brain lights up the concept of beach.
Simple enough.
But the more powerful one for dialogue is co-activation.
Which is like the ripple effect.
Precisely. If I say beach, your brain doesn't just stop there. It ripples out to ocean, sand, sun, towel.
Ice cream, maybe.
Yeah, ice cream. The researchers use the example in the paper of can and pan.
Right, can and pan.
They sound similar, so there's that phonetic link,
Uh-huh.
but they're also semantically linked. You heat a can of beans in a pan. So when I say one, your brain is already warming up the other, getting ready for it.
So in a successful conversation, we're constantly preloading each other's brains.
Yes. We're laying down track right in front of the train.
Mm.
And when that works perfectly, we build a dialogue lexicon. We create a mini language just for us, just for this interaction.
They had a great transcript example of this negotiation in the paper. It was really subtle. Speaker A says, "Look at the streetlights." And then Speaker B says, "You mean the street lamps?"
A very subtle correction.
And then Speaker A just goes, "Yeah, the lamps."
And that right there, that is the magic moment. Speaker A proposed lights. Speaker B countered with lamps. Speaker A accepted lamps. Now, for the rest of that interaction, lamp is the law. They've aligned. They've created a local rule for their reality.
Okay, so that's the psychology. We're trying to build this shared dictionary in real time. But the researchers didn't just want to describe it, they wanted to measure it mathematically, which is where we get to the Titan model.
Titan, the two-level time-aligned network.
It sounds like a weapon system from a sci-fi movie. Target locked with Titan. But it's actually a way of visualizing conversation. Walk us through this, because this is where it gets really visual. How do you turn talking into a shape?
Imagine a blank white canvas.
Okay.
The moment our conversation starts, the model begins to draw. Every single word we use becomes a dot, a node on that canvas.
Okay, so if I say lamp, a dot appears labeled lamp.
Exactly. Now, the model draws lines or edges between those dots based on when they're used. And it looks for two specific kinds of connections. First, it looks at interpersonal links.
Interpersonal, so inside one person.
Right. It maps your own internal consistency. Do you keep using the word lamp to refer to the lamp? Or do you switch to light, then fixture, then thingy? If you keep switching, your internal graph is messy.
Okay, so that's mapping my own stability.
But the second level is the interpersonal links. This is the bridge. This connects my dots to your dots. If I say lamp, and then 10 seconds later you say lamp to refer to the same object, the model draws a thick line connecting my word to your word.
So if we're totally in sync, if we're vibing perfectly,
The graph becomes this dense, interconnected spider web. My words and your words are just woven together tightly.
and if we aren't, if we're arguing about the tree,
Then you get what they call the lower bound of alignment. The graph looks like two separate islands. My cluster of dots is over here, your cluster's over there, and there are no bridges.
we're just talking past each other.
Completely.
And the researchers claim that just by looking at this shape, is it a web or is it islands, they can tell if the communication is working.
Yes. They actually use the term isomorphic.
Isomorphic, that's a $10 word.
It is. It's from Greek. Iso means same. Morph means shape. In a theoretically perfect conversation, my graph and your graph would be identical mirrors of each other.
But that never happens in reality.
Never. But the closer we get to that same shape, the better the alignment.
So to test this, they couldn't just record people chatting about the weather. They needed a task where there was a clear win or fail state.
They use the Saiga corpus, the Bielefeld speech and gesture alignment corpus.
Which is a very serious name for what was essentially a video game bus ride.
Basically, they took 25 pairs of people. One person, the direction giver, watches a simulation of a bus driving through a virtual town. They see parks, churches, some weird sculptures.
And the second person, the follower, can't see the video.
Right. So the direction giver has to describe the route well enough that the follower can trace it on a map and find a specific destination.
Specifically, they had to navigate from a sculpture to a fountain.
Exactly.
It sounds simple. Go past the church, turn left, there's the fountain. But 25 pairs, how did they do?
Not great.
Really?
Out of 25 pairs, 17 failed. They were classified as ineffective.
17. That's a failure rate of almost 70%. We are really bad at this.
We are. The directions were confusing, the follower got lost, and they never found the fountain.
So only 8 pairs were effective.
Only 8. But here is where it gets really interesting. They split the effective group into 2 classes. Class 1 was perfect. Great directions, found the fountain, no problem. But Class 2 found the fountain, but the directions were technically factually wrong.
This is my favorite part of the study, the leaf tree incident.
Right. In the simulation graphics, there were conifer trees, pine trees, needles, cones, the whole works.
Okay.
But one pair kept calling them leaf trees.
Which is biologically false.
It is. But And this is huge. It didn't matter.
It didn't matter.
Nope, because they both agreed to call them leaf trees. The listener knew what the speaker meant. The alignment was successful, even though the facts were wrong.
That is a profound point we need to circle back to. The idea that agreement is more useful than truth. But first, let's look at the failure. The researchers took these transcripts, the winners and the losers, and fed them into the Titan model. They wanted to see if the computer could sort them just by looking at the network structure.
And remember, the computer doesn't know what a fountain is. It doesn't know where the bus is going. It just sees the nodes and the edges.
And this leads to the big reveal. The nouns only surprise. This is where I got stuck because it feels completely counterintuitive.
It does. It goes against everything we learn in, like, creative writing.
Right. If I'm giving you directions, I'm thinking I need to be descriptive. I need action. I need verbs. Turn, walk, go, run. I need adjectives. Big, red, old. I assume that more detail equals better communication.
That is the intuition. Paint a picture. Be specific.
But the Titan model said, actually, no. When they ran the algorithm looking only at the nouns, ignoring every verb, every adjective, every preposition, the model could predict the success of the conversation with 96% accuracy.
96%.
Yeah.
Just by checking if the nouns matched up.
But wait, hold on. How can that be? If I just say building.straight.fountain, that's not directions. That's a grocery list. How can ignoring the verbs make the prediction better?
Because when they added the verbs back into the data set, the accuracy dropped to 92%.
No way.
And when they added adjectives, it dropped even more.
So adding more information made the model dumber. That makes no sense.
It makes sense if you go back to the situation model.
Mm-hmm.
Think about what a noun does. Nouns anchor us to the reference universe. They represent the things in the world, the church, the park, the bus.
The pylons of reality.
Exactly. If you and I agree on the things, if we were both looking at the same church, we are 90% of the way there. But verbs and adjectives, they're relational.
Relational meaning. Dependent.
Dependent on the noun. Imagine I say, turn left at the big, white, beautiful house. Big, white, and beautiful are adjectives. But they're useless if you are looking at a shed and I'm looking at a mansion.
Ah, I see. So if we aren't aligned on the house, describing the house is just noise.
Exactly. It's worse than noise. It's misleading.
Yeah.
In the ineffective dialogues, the ones where people got lost, the problem wasn't that they weren't descriptive. It was that they were describing the wrong things, or they were describing things the listener couldn't identify.
So when the algorithm included adjectives, it was essentially confusing itself with all that bad data. The clear signal was always in the noun.
That's it. If the nouns don't align, the bridge is broken. It doesn't matter how beautifully you decorate the bridge with adjectives. If the pylons aren't in the ground, you fall in the water.
This really flips the script on how we talk. I always thought being a good communicator meant having a rich vocabulary, being flowery, but this suggests I should just be a caveman. See rock, go rock.
Well, maybe not quite caveman. You still need to say turn left. But certainly you should prioritize the what before the how. Secure the noun. Once you see that the other person has accepted the noun, once that edge is drawn in the graph, then you can add the adjectives.
But not before.
Not before.
Now, they also looked at metacommunication. These are the things we say to manage the conversation itself. Phrases like, do you understand? Or, wait a second, or, okay, got it.
Right. The organizational talk. The housekeeping of dialogue.
And I've always been told that active listening is key, nodding, saying, But the study found something interesting here too, didn't it?
They found that including or excluding these meta words had almost zero effect on predicting success.
That's harsh. So asking, do you get it, is useless.
Structurally,
Yeah.
yes. Because saying I get it is a binary check. It signals, yes, I am listening. But it doesn't prove, yes, I share your map.
I can relate to that. I have definitely nodded at someone while having absolutely no idea what they were saying, just to be polite.
We all have. You can look someone in the eye, nod, say, I completely understand, and be thinking about a totally different street corner. The meta talk is superficial. The map is built by the nouns.
I want to bring up the Peichenlamp.
Ah, the Peichenlamp.
Yeah.
The wick lamp.
This was a specific moment in the study that I think perfectly illustrates this noun power.
So in the virtual town, there was a street light that had a very distinct shape. It curved way over the street like a whip.
And German, the language of the study, didn't have a standard word for this specific weird light. It wasn't just a normal Straßenlampe.
Right. So the participants did something brilliant. They improvised. They took Peitsche, which is whip, and lamp, which is lamp, and smashed them together. Peitschenlamp.
A neologism. A made-up word.
But in the context of the Titan model, this is gold. Because the moment speaker A says Peitschenlamp and speaker B accepts it, they have created a unique identifier. They have named a part of their world.
It's an exclusive club. If I walked in and heard whip lamp, I'd be confused. But for them, it's the strongest link in their graph because it is so specific.
It shows that alignment is active. It's creative. We aren't just selecting words from a dictionary. We're building a language to fit the reality we share. The graph for Peitschenlamp would show this massive, strong connection between the speakers.
Which brings us to the why. Why did the ineffective groups fail so hard? 17 out of 25 is a bad score. Was it just that they were lazy? Or that they didn't invent cool words?
The researchers suggest it goes deeper than vocabulary. They call it the fragmentary problem.
The fragmentary problem, it sounds like a hard drive error.
It basically means the direction giver had a broken map in their own head. Their mental model had gaps. Maybe they remembered the fountain, but not the street leading to it.
So if my map is broken, I can't possibly help you build yours.
Exactly. If the source material is fragmentary, if the graph inside my head is disconnected, then my speech will be disconnected. I'll struggle to find the nouns, and if I can't offer you the nouns, we can't align.
So those class 3 failures, it wasn't just bad communication, it was a failure of internal knowledge.
Which is why the noun analysis is so predictive. If the nouns aren't linking up in the conversation, it's a symptom that the underlying mental model is fractured. You can't explain what you don't understand.
This has massive implications beyond just giving directions. Think about a workplace. You're a manager explaining a project. If you find yourself using a ton of buzzwords, a ton of adjectives, it needs to be dynamic, robust, scalable, but you aren't pointing to specific, concrete nouns.
And you probably don't know what you want.
Ouch.
But true, the Titan model would look at that manager's speech graph and see a lot of unconnected nodes. No structure, just floating adjectives.
And the researchers actually envision this being used in real time, right? Like an AI assistant for critical conversations.
That's the dream application.
Yeah.
Imagine air traffic control or emergency response teams. You could have a system monitoring the dialogue channel. It wouldn't need to understand the complex jargon of aviation. It wouldn't need to know how to fly a plane. It would just watch the topology.
It would watch the shape of the web.
And if the graph starts looking like two separate islands?
It flashes a red light. Warning. Alignment dropping. Verify nouns.
Exactly. It could save lives by catching a misunderstanding before it turns into an action. It essentially acts as an objective third party saying, you two think you agree, but the math says you don't.
That is incredibly cool. And also a little bit Big Brother, but mostly cool.
It changes the definition of listening. The AI isn't listening for keywords. It's listening for connection.
So let's bring this in for a landing. We've covered a lot today. We started with the car argument. We went through the interactive alignment model and priming how our brains warm up related words like can and pan.
We looked at the Titan model, the visual graph of our conversation.
We talked about the saga experiment and the nouns-only surprise. That 96% accuracy comes from ignoring the adjectives and focusing on the anchors.
And we learned that do you understand is often the least useful thing you can say.
So what's the big takeaway? For someone listening to this who just wants to have better conversations or just wants to stop fighting with their partner in the car.
For me, it comes back to that class 2 finding, the leaf tree.
The wrong but right scenario.
It proves that communication is not about truth, with a capital T. It is about agreement. You don't need to be objectively, scientifically correct to be effective. You just need to be aligned.
If we both agree the conifer is a leaf tree, we find the fountain.
Exactly. Don't let the pursuit of perfection get in the way of connection. Secure the shared noun, even if it's a made-up one like Peitschenlamp.
I want to leave everyone with a thought to mull over today based on that exact idea. We spend so much time in our lives, in politics, in relationships, on social media, obsessing over facts. Being right, correcting people. We say, actually, that's a conifer, not a leaf tree.
And usually that stops the conversation dead in its tracks. It breaks the alignment.
Right. So here is the question. Is it possible that our obsession with factual correctness is actually destroying our structural alignment? If the goal is to navigate the world together, to find the fountain, maybe we need to worry less about whose map is true and more about whether our maps match. Maybe, sometimes, it is better to be wrong together than right alone.
This is a very provocative thought.
Yeah, something to think about the next time you're in the passenger seat. Thanks for diving in with us.
See you next time.